Now that you know what this problem-solving course is all about, it's time to introduce some of the technology tools that will help you to become an effective problem solver. Technology has always been an important factor in facilitating problem solving. Shown here is an image of an abacus, which is an early tool that was used for information storage and organization, calculation, data visualization, and communication, all of which are still issues in problem-solving technology today. Of course, we've come a long way over the years, and each month brings to market new technologies that provide faster, more flexible, and easier to use ways to engage with every aspect of the problem-solving process. For example, advanced sensors and data tracking tools for everything from commercial to personal use help us to capture information effectively. Meanwhile, hardware, software such as databases, and hybrids of the two, embodied in the cloud computing revolution, allow us to store and organize that information. Analytics software packages, dashboarding software for data visualization, and adaptation of advanced mathematical models to automated software packages help us to analyze that information in ways that lead to greater insight and effectiveness in all areas of life. And finally, advanced data visualization tools and collaboration and data manipulation techniques allow us to share and communicate information with others. You probably hear about and interact with many of these technologies on a daily basis. Let's look at a few extraordinary examples. Shown here is a screenshot from Google Analytics, a web-based software package produced by Google that allows online merchants to understand how their web-based ads attract customers and which advertisements are most effective in getting customers to engage in the way that they wish with their online stores, for example, by making purchases or referring friends. Shown here is an advanced sensor created by Proteus Biomedical that can be embedded in medications, ingested, and then tracked remotely on mobile devices and computers by healthcare providers and their patients so that patients can make more informed decisions and gain a better understanding of their overall health as it relates to their medication intake. And finally, Renaissance Technologies, one of the world's most successful hedge funds, has successfully adapted advanced mathematical models to predict inefficiencies in the stock market and make great profits, providing liquidity for markets worldwide. Such tools can leverage multiple technologies to achieve amazing things. Of course, they may be intimidating, and the expertise may seem prohibitive at this point. But you'll be happy to know that proficient use of just a few technology tools puts great power to collect, organize, analyze, and share information at your fingertips. Once you have mastered a few basic tools, you may find that you crave additional functions, and more specialized software packages will be able to complement those needs. For the purposes of this course, we'll look at three main technologies: calculators, which are used for general computation and are beneficial for their portability and speed; Excel, a classic spreadsheeting tool that provides a variety of functions, including moderate data storage, organization, calculation, and visualization, as well as being highly flexible and easy to use; and databases, which are large-scale data storage and organization tools that are not used directly for mathematical calculations, but facilitate the use of multiple software packages. Let's look at calculators first. There are three main flavors of calculators: standard, scientific, and graphing. Standard calculators, like the one shown below, are used for basic mathematical computation, addition and subtraction, multiplication and division, roots, and percentages. One step up are scientific and specialty calculators. These add additional functions which may be mathematical, like powers, exponents, logarithms, trigonometry, or general measurement conversion, or may be designated for special applications such as engineering or even cooking. And finally, in the most advanced category are graphing calculators, which allow graphing and analyzing of functions, graphing of data and discrete data points, calculation of advanced exponentials and roots, storing and plotting of data, as well as saving of functions and uploading to computer or sharing among calculators to facilitate further analysis and collaboration. When a calculator just won't suffice, Microsoft Excel is your next choice. The classic spreadsheeting tool is used to store data in rows and columns. It's easy, all-purpose, and provides data storage for relatively small volumes of data, but still much more than a calculator, up to 300,000 rows. Excel is hands-on. It allows for direct manipulation of entered data with a cursor and keyboard, and it's extremely flexible. It allows you to organize data, perform calculations, carry out statistical analysis, perform computations on large volumes of data at once, and build tables and graphs. Let's look at an example of a Microsoft Excel spreadsheet. Shown here is a spreadsheet that shows a tabulation predicting the cost of fruit prices, or snacks, for an 8-week summer camp. The price of apples and oranges is given in the top of the worksheet and is followed by a table denoting the number of apples and oranges purchased in each of the 8 weeks of the camp, as well as the calculation of the estimated cost for those snacks. In the bottom right-hand corner is the total cost over the course of the entire 8 weeks. Some of the data in the spreadsheet was entered manually. The price of the apples and oranges, as well as the number of apples and oranges per week, were typed in. Other elements in the spreadsheet were calculated. Shown here is the formula used to calculate cost, which is the price of each of the fruits times the quantity, summed together to give the cost per week. Built-in functions in Excel, like the sum function, allow for easy calculation across multiple data values. Shown here with the green arrow, you can see the formula used to calculate the sum. The elements that were summed are highlighted in blue, and the formula describing the way the number should be entered to maximize the effectiveness of the function is denoted by the purple arrow. One of the beauties of Microsoft Excel is that there are multiple ways to calculate anything. One way to calculate different scenarios for price, if the price of apples and oranges over the summer is uncertain, would be to copy this table, enter different assumed values for the apples and oranges, and observe the change in the total cost and the weekly cost in the right-hand column of the table. Alternately, one could simply manipulate the final value of the table, the total cost, by multiplying it, say, by 0.5 to get the half number, or by 2 to get the double number. One could also analyze the trends in price over the course of the weeks using the graphing functions. Graphed here is the total cost of the fruit as well as the number of fruit units for each fruit. You can see that week number 5 has the greatest cost as well as the greatest numbers of fruit, so you can see what's driving the cost. These kind of tools are extremely useful for a variety of applications. Microsoft Excel will likely be one of your best friends within just a couple of weeks of beginning to use this tool. The final tool that we'll consider in this course is databases. Databases are used for collecting and storing large amounts of data. The database consists of multiple tables linked by codes to indicate clusters of data that belong together. Data is then removed from the database using a query, literally a question, entered by the user. The user may enter the query either using a query language, such as SQL, which you may have heard of, or they may use a user interface, which is a program that links to a database. This is the most common format. Databases afford great flexibility in how to call up and format information from huge amounts of data. It makes data more manageable and allows you to just look at what you want in whatever format you want at a given time. Databases are highly useful for large research studies, which require correlation of multiple variables, and for collecting and storing information from monitors and sensors over a long period of time. Databases are not typically used for on-the-fly data manipulation, calculations, or visualization, but they're still an incredibly powerful tool. In addition to the tools that we'll study in this course, there are many more advanced tools. Hundreds of, if not thousands, of specialty tools, public and private, are created each year for working with data. Building customized programs is a career for many programmers, and there's an entire consulting industry based around the need to create custom tools for various applications. Common commercially available tools include advanced programming environments for C and Java, which will allow for complete flexibility in building customized tools, statistical software and data visualization tools like JMP, Minitab, SAS, SPSS, and R, which allow advanced statistical analysis, modeling software to perform complex math operations such as Mathematica or MATLAB, used by engineers and scientists, as well as tools for monitoring data or dashboarding, like those produced by Google Analytics. With calculators, Excel, and databases, most everyday powers are within your grasp, however, and you'll become facile in using and understanding where these tools can be used in the course of this class.